For our first example of calculating standard deviation, we're looking at the observations 0, 1, 2, 3, and 4. When we go to calculate standard deviation, the first thing we do is list. I need to list x bar, that is my average, and n, my sample size. Now, in total here, there are 5 things. That's easy enough. And remember, to find my average, I can add up all those numbers. And if I add them all up, I get 10. And then I can divide by the number, so divide by 5, and I get 2. I want you to notice my average is 2 and my median is 2. If my average is equal to my median, remember that means my data is symmetric, which is an important realization to have here. Step 2, I'm going to go ahead and create my little table. I start my table by listing all my x values, my observations. This is 0, 1, 2, 3, and 4. I then find the deviation of each one. That is how far it is off average. So I'll take 0 minus 2, which is negative 2. 1 minus 2, negative 1. 2 minus 2 is 0. 3 minus 2 is 1. 4 minus 2 is 2. Now notice if I add these up, they add to 0, right? Which is why we don't add them right away. That's bad. Instead, we square them. And we square them once again so they don't add to 0. If I square those values, I can write that square over here. If you're plugging these into your calculator and squaring them and getting a negative, that's because on a calculator, you need to plug it in as parentheses, negative 2n parentheses squared. That is, you need to make sure that negative is under the square as well. Advice, just leave off the negative if you're in square it, because you know the negative should drop off anyway. Step 3, I'm going to go ahead and add all these together. So, if I add these up, it looks like I get 10. Next step, step 4, is I'm going to go ahead and average them. And I average by dividing by n minus 1. That is, I'll take 10, dividing by 5 minus 1, which is 4. My 5th step, because I've squared, I need to go ahead and square root. So square rooting it, I get square root of 10 over 4, and this will be my sample standard deviation.